Hey, folks. It is my pleasure to present you Viktor Bonev. He's going to talk about a very serious topic called secure FIPS containers for government services.
Thanks a lot. So I hope this will be a really nice talk for every one of you. And I see a lot of smiley faces and a lot of people who are encouraged and probably interested in security. So I hope during this presentation you can learn something that's very valuable. And we're going to start with a really interesting topic. It will be about the FIPS containers and how do you make them secure. Particular applications may include that this work will be contributed for government services. And I will explain and walk you through what are the important stuff and what makes this really cool and kind of the holy grail of the security in our essence. So we're going to start with what is FIPS. In short, FIPS is the Federal Information Security Processing Standard. It is a US government computer security standard. And you can see that there is 142 as a denominator. So 140 precisely talks about ciphers. So we're going to cover FIPS in regards to its ciphers and more emphasis on this one. And the second one, which you see over here, is the revision or the version of that particular document that describes how security should be established. Whenever you're dealing with Federal Information Processing Standard, whatever that's applied, we're going to look where this is applicable and what makes it so cool and unique. So, going to the business overview, the main players in this field, and you can see a lot of bald eagles and logos. The particular guys that love FIPS are usually the federal governments of the United States. So whenever you're creating an application or you're kind of need to work with services that are created with government, for government purposes, or they're getting government data in any way, processing or consuming, you need to be FIPS capable. We will talk broadly what means FIPS capable and why many consider this going through hell of security. But many of the key players includes the Department of Defense of the United States, Departments of Energy, Commerce, Justice. There are many more, but that's how this came to life and that's how it is established. Of course, there are many more, and we're going to see that this does not only apply to United States only, but it applies also throughout Europe, and that will become more and more frequent as we will unfold. So this started as a US idea, implementation, then it was approved by many folks who were dealing with security many years, and some of the top experts worked on this. But for quite a lot of years now, it is becoming a global standard for security. And there is one player, which is ENISA, and ENISA is kind of the European agency for cybersecurity. So you can see that this now not only works for the United States, but it works through government services or foundations that are getting started in Europe. And that started around 2008, so this European Union Agency for Cybersecurity is established. It covers more and more of how we should deal with security across Europe for our government services, and it is great. So we have that in place. It works alongside the EU institutions, EU municipalities, so all the towns and governors that do govern those capitals, towns, whatever the place are. And basically the question towards Europe is that we wanted to make it more and more secure. So there was this need for more security to take in place. And basically, as each one of us wants to be enforcing Europe and the European Union alongside with its governments and institutions to be more secure. And everyone states, hey, come on, let's be more secure on this one and how we can achieve that. So keep in mind that our federal agencies, their contractors, and service providers must be compliant with FIPS as well. So we'll see on the next slide how this unfolds and how what the business cases looks like if your company or the company you work for decides to implement this, and what will be the benefits. So what are the application scenarios that we can think of? So imagine I'm writing a very nice piece of software. Suddenly I have a business case where someone that's connected with the federal government or operates with data provided by the federal government or any institutions, might be EU institution as well, process that data. Then I have to be compliant as well, and I have to be FIPS compliant. So I have to obey everything that's written on the FIPS guidelines and how to make my applications and containers secure. So what are the scenarios? So imagine that you can obtain some fire and safety building plans, construction allowances, and update status requirements, and you process this data. This usually is confidential. I'm sure many of you have watched many spy movies, James Bond, etc. Then they go through a ventilation shaft. So that could be considered highly classified secure information. And many buildings which operate under stricter security terms consider this classified data. So in order to process this information, you need to be FIPS compliant, and either you can communicate it with third-party provider. That's just one example. The next one would be you can obtain some non-military information, and we can see that those things can become even military information, can be really valuable as unprecedented times are coming, and we see it more and more often. So you can update third-party logistics, out of the logistics that's needed to be updated, packages to be delivered, whenever there is a need to. Of course, that has to be strict and classified. Whoever processes this needs to be compliant, and if you contact or interact with this data in any way, you have to be compliant with FIPS as well. Next example will be, imagine that you obtain some kind of a personal or commercial tax billing information, something that we have also in the Bulgarian government as well. You send that respective request to the bank. There is a bank secret, as you know, so some of this information is either sensitive or classified depending on the use case, but you go through several types of verification process, and usually it connects now more and more with your digital identity. So those are talks that will be far more frequent. This is one particular use workplace that you can apply out of those FIPS compliance, and that's how you create your application and services secure by the latest trends. So where are we going to deploy this? Of course, you can do it. The whole environment needs to be FIPS secure. That's usually very hard to achieve and a lot of time consuming. You need a dedicated team who does security for you. Of course, there are some cloud solutions that can make the job much easier for you because they already have went through the certification process. They went through all the verification stuff. One of those service providers, of course, it's a very big cloud provider. It's Google Cloud. And you might not have heard, or you might have heard, if even better, if there is a certain use case for government. So usually there are many more requirements when it comes to security for certain government institutions. You can take Australian government, the Netherlands, the Dutch government. So there are many places where if you obtain information, it has to be very secure. One way to do it is through Google Cloud for Government. That's how the service is called. So it is entirely FIPS compliant end-to-end, and it's starting to grow as a trend. So specific use cases for cloud, since cloud by design is not really secure, so you have to put many things on top. It has the basic security in place, but whenever you need more, you definitely need entirely new solutions. One of the biggest cloud providers, started working on this one, and it's already providing it. Next one is AWS GovCloud. It is unfortunately only for US. Same holds still for Azure. So they provide something that's called Azure Government. Fortunately, still only for US only. It's not the technology doesn't allow it, but it's more like regulations, laws, and stuff like that. So now we come to the more interesting part. What makes FIPS? And there are, as I refer to them, the four horsemen of the apocalypse, the compliance itself. And many freak about this, so how I can create my application secure, and there is Joey from France who freaks out, same as we as a developer freaks out in how to make our application secure, and respectively the environments and the containers where they operate. So I will briefly walk you through them. So those are the core aspects of security. So we have symmetric key, and we have digital signatures, we have secure hash, and we have also message authentication. Keep in mind that a simple process as an SSH into a server, so establishing an SSH tunnel session into one of your servers, uses already 3 of those aspects. So it is a complicated, and usually they work in between. Since we're on 142, 140 is for ciphers, we have to denote which is applicable to each one of those 4 horsemen. So for symmetric key, the ciphers which are allowed is, of course, we have IS, which is the advanced encryption standard, and triple DES. So in order to be FIPS compliant, symmetric keys has to be either one of those 2. The next one will be digital signature. So we have DCA, RSA, ECDCA. So the last one is a bit of an interesting one. It's connected with the elliptic curve. So you might have heard it. It's a mathematical model how to establish security. It works only for digital signature. So if you have a symmetric key, it won't operate with elliptic curve cryptography. The next one is a secure hash. You might have heard many of those ones, especially from previous talk. All of the crypto stuff is based on some kind of a hashing to make it work and operate. So the applicable is SHA-1, SHA-256, 512, and SHA-3. So those will be compliant in terms of hash. No other hash is allowed. And for message authentication, it gets the same thing that are applicable for symmetric key, but it adds also HMAC. So that's very important, and we'll see why is that in the next slides. So the presentation, now we have the background, what is FIPS, how we can apply it in real life. So we have this thing that's really a buzzword, Kubernetes, Docker, and we want to create those fantastic containers which are secure and on point. So keep in mind that we have to have a clear distinguishing between what is a build container, what is a runtime container, and an image. Actually, the container is the running instance of an image, which we have already described. So the build containers could be, you can build native code, such as Go, C++, Rust. You can also have an image which builds Python. You can have an image which builds Java Spring via JDK, and we'll see how is that achieved. And you can also build Node.js, but we're not going to look into this one. Keep in mind that it's completely separate in terms of when you have to run those pieces of software on the cloud. So the left side builds your software. It's not used in production by any means. On the right side, you have your runtime images, which do run your product, software, service, whatever. So you always have a runtime base, which is your sort of like core runner and your template for that everything steps upon. Then you extend that and you inherit what's in the base image. We have runtime Java via the Java runtime environment. I also have a runtime Node.js. We're not going to look into this one, but the lesson to take home is that those are 2 completely different types of images, and you shouldn't intermix them. So use only the runtimes in production when you're running instances, the build ones only in your build environment. So for the base, for the runtime base, what you need to have, and in its essence, is for security is OpenSSL. And to have FIPS running, definitely you have to run OpenSSL in sort of FIPS mode. That's how it's called. For this to be achieved, you have to have a certain specific build. So you compile OpenSSL with FIPS. And there are certain dedicated already builds for the different, of course, flavors of Linux, distributions, and so on. But if it's not there, you can just compile it on your own, and you get your OpenSSL build. Keep in mind, of course, that the base image or the Docker image, it should be based on an open container initiative for best security practices, meaning that it holds the OCI standard. So that's short for Open Container Initiative. And it should contain this OpenSSL FIPS, running in FIPS mode. So what would be the implications of such FIPS enabled? Let's say I have a Python app which tries to perform MD5 hash operation, or I have a Python app which tries to connect via weak encryption to a database. This is like the whole world when it comes to the examples. So I'm not going to bother you with something that's more difficult. What will happen is if I want to have an MD5 function code and apply it anywhere in my code, I will get this running in a FIPS environment and an image that contains OpenSSL FIPS. I will get digital envelope routines, and usually there will be some error. I will say that that's either unsupported or intercepted by any means. This means since Python is using OpenSSL for most of its function, actually all of its function when it comes to base functions and standard library, it will be intercepted and your application won't be able to make that call. So that's in essence what FIPS does. It kind of intercepts whenever you do something wrong. So it won't allow you to perform that action. For Go, it used to be quite different until recently. So Go uses the so-called boring crypto library. So boring crypto library is a FIPS certified library. And if you have Go products or services, if you want to implement FIPS, they used to have a dedicated build, so you had to compile Go with FIPS. That's no longer the case. You just need to have a variable which is called Go experiment, and you set its value to boring crypto, and voila, you have your FIPS capabilities in Go are enabled. So that's really cool that they have done this, which means FIPS is getting more and more applied into even discovery phase for companies. So the next one is Java. Java is really tricky. It's always been the case from, from my perspective. So what Java does is they use another library, which is FIPS certified. It's called Bouncy Castle. They're kind of like, they call themselves the Legion of Bouncy Castle. It's very good library, very secure, of course. It is FIPS certified. It supports only 3 versions of Java so far, Java 8, 11, and 17. So keep in mind, if you use older version of Java, this will not work. Those are the approved ones. So what you need to do in order to get that running, Java comes in the Java runtime environments, it does come with a default so-called security provider, and it's called Sun Security Provider since the original developer for Java is Sun Microsystems. And you need to remove all those garbage which we consider unsecure and replace it with Bouncy Castle. Then you have the same capabilities similar to what I showed you with Python and OpenSSL. Whenever you call something weak in terms of ciphers that are weak, it will be intercepted, it won't be allowed, it will be just shut. There are 2 Bouncy Castle providers. Keep that in mind, since even one would have been difficult, but there are 2. So there is JCA, JCE, which handles all the encryptions, which have all the ciphers that you need to use and perform. And the next one, which is kind of a extension, is the JSAC, which adds SSL and TOS. So to get that running, you need to exchange the default Sun microsystem security provider and plug those 2 Bouncy Castle providers. And everything will work as designed. So getting into this configuration might be tricky. So I will walk you how this could be achieved for Java. And it's kind of a difficult process. It's not very obvious, but the main stuff that needs to occur, that every certificate that you use, and it's in your certificate store or trust store, has to be added to the Bouncy Castle key store. And this has to be applied to every certificate, of course. Then the Java by design comes with a default security provider file, which contains all of its configuration, how it should start, what should be running. It's really low level, but it's really interesting, and I encourage everyone who deals with Java to take a look and see how this works underneath. I've been taking this for granted for a long time until I had to do FIPS. So I understood a lot about security and how Java operates behind the curtain. So I encourage everyone to take a look and check the security providers. So there's really cool stuff that you can change. So you can change the very essence of security in Java. And that's the whole idea with this. And in order to create your custom Java FIPS container and an image, you have to, of course, modify the way Java is being invoked. So you have to modify the startup arguments. And I will just give you an example of how this looks like. So first of all, you already have exchanged the Java security properties. So you can point it to an override of this security file. Basically, you plug in our view configuration, how Java should operate, exchange the Sun microsystem providers, say where the bouncy castles providers are, and say that you only will approve FIPS approved stuff, no ciphers that are weak. Also set the key store to the desired one, which is secure. Set the trust store, which is the opposite of key store, and also set the trust store path, the trust store password, and also mention some stuff about that we should use the newest TOS, which is 1.3, which is considered secure. So you have to perform those actions, and you'll get every applications running in FIPS with Java. And it's really cool. And you'll get the behavior the same as the Python application. You'll get all of the weak ciphers or methods that are completely unthinkable when you're dealing with government data, completely intercepted. So that's really cool. That was all that I wanted to mention for FIPS, and thanks you all for your attendance. So I'll open it for questions. I believe we have time for 2 questions, so maybe 3 if we're lucky.
Well, no questions for now, but definitely I enjoyed the way you structured all this information. I'm not quite sure that I understand why do you think it's cool, all these options for configurations. Can you repeat this?
Yes. Well, I personally consider it cool since the question is usually when a manager comes in, you have done all of the things you consider that you have secured your application, you've done all your due diligence, and at the end he asks you, sort of, are you sure that this is secure? So if you apply this, there is no way, this answer will be, I'm not sure. You have gone through the roughest of certification processes that exist in security, and that's the federal information processing standard. So that makes it cool, because there is nothing that tops this in terms of security. Yeah, there are different levels on this, so you can have stricter requirements on FIPS, but nothing beats that. So that's why governments use it. That's why one of the things we have watched as kids for movies, the CIA, the NSA, they all thought about this and they implemented it. So that's really cool. Shoot.
Yeah. So my question is, if you, let's say, are given or provided a bunch of images by somebody and they say, okay, these are the FIPS compliant images, what would be some 3 easy steps to validate that this statement is true? How do you check?
So I can give you a very quick answer since this was a question which I asked myself as well. There are tons of bundles where you run, and this checks pretty much like a sanity check for whether this is valid, and they're valid for different tech bundles. So if you have a product which is C++, native language, etc., it's another bundle. So if you have something that's Java, it's another one. And I don't know how many tests there are. I believe over 1,000 for one bundle, and they run really rough tests. So if the application passes this, or the image passes this one, in that particular case it will be the image, then you can consider this environment FIPS capable. FIPS capable, right. And now how enforced you wish the level would be, that depends on your security guy at the company, right? How willing is he, or how persuasive you are in terms to, get the thing that you wish, and what's best for the company, of course.
Okay, maybe one more question. No? Okay, thank you, Viktor. That was amazing.
Thanks.